Okay, so Mehrdad is a PhD candidate at the University of Toronto working on the design and optimization of net zero energy buildings under uncertainty. Mehrdad has a BSc in mechanical engineering and an MSc in energy systems engineering. So thanks for joining us, and I will pass it off to you.
Okay, thank you so much, Noah, for the introduction. So let me just share my screen with you guys. You should be able to see the slides now.
Go.
Okay. Can you guys see my slides? Okay,
Yes.
great. So yeah, today I'm going to talk about net zero energy buildings, the influence of definition on the greenhouse gas emissions of that resulted building. But before doing that, I want to tell you like the story behind it. When it comes to choosing a definition for net zero energy building, there's a lot of perspectives to consider. And one of these perspectives, which actually is kind of overlooked in the literature, is the influence of definition on the greenhouse gas emission of the building. So I will try to close that gap for you today. So to start, I'm going to give you a very general definition for net zero energy building. So in the broadest sense, net zero energy building is a highly energy efficient building which is connected to the grid, which has a two-way connection with the grid and produces as much energy as it consumes over a specific period of time, which is usually a year. So these are the three key features of the concept. So it encourages energy efficiency. Net zero energy building is very energy efficient. It has a two-way connection with the energy grid, and it requires on-site renewable generation. If you're familiar with the topic, you know that there are many different definitions for net zero energy buildings available in the literature. So today, I'm going to just focus on 4 widely mentioned definitions that actually orbit around this word energy, or it's better to say what we're trying to achieve a net zero balance for. So 4 widely mentioned definitions in the literature are these. So net zero site energy building, which says, okay, you have a building, you're consuming a specific amount of energy on site, so you have to generate the exact same amount of energy on site. And so you create a balance between consumed energy and generated energy. The second one is net zero source energy building. It's very similar to the first one, but the idea is, okay, let's convert both consumed energy and generated energy to primary energy or source energy in this case, and then create a balance between those two. The third one is net zero energy cost building. So the idea is to design a building that doesn't pay any utility over a year. It's very attractive. It's the easiest one to sell because like everybody understands money, in my opinion. And the last one is net zero emission building. So when you have a net zero energy building, you will consume some energy from the grid. You will produce some emission anyway. But on the other hand, at the same time, you will export some renewable energy to the grid. So in other words, you're going to display some electricity, for example, on the grid, which would have been generated using fossil fuel otherwise. So you're receiving some emission credits. And the idea is to create a balance between produced emission and received emission credit. And by the way, we're following CAGBC zero carbon building standards. So CAGBC came up with a standard for net zero emission, your net zero carbon buildings in 2016, which is amazing, which was a great step forward. Okay, now that we know our 4 definitions, we have to create some context because as I already mentioned, these 3 definitions depend on some external factors. So it's not easy to compare them without a context. And to create that context, we said, okay, we're going to create a very simple geometry, a cubicle in Toronto, which is only going to use PV panels to generate renewable energy. And to be more comprehensive, we said, okay, we considered 2 different options for the energy mix of the building. So building can be only electricity or it can use electricity and natural gas, and it can have 2 different energy behavior. It can be commercial or residential. So these combined result in 4 different energy scenarios. And to be fair, we said, okay, we want to keep the EUI, energy use intensity, between all these energy scenarios constant, but the GHGI or greenhouse gas emission intensity of these buildings can be different. As you can see, it ranges between 15 and 17.5. Okay, we have the context, and let's look at the result. Let's look at the effectiveness of these definitions in reducing emission of a building. So as you can see, these are our base cases ranging between 15 and 17.5. We have emission definition as the least effective one actually. So it can reduce the emission of the building between 49% and 6%. In the next place, we have source definition, 74 to 108% reduction in our GHGI. And by the way, these green regions represent a net negative emission building. So that line of 0 is the boundary between being net positive and net negative. So source definition can be net negative. We have site net zero energy site definition in the second place, which will allow us to reduce our emission by 92 to 108%. And we have at the top cost definition, which will be always a net negative emission building in the context of this study. And it allows us to reduce our emission by 102 to 145%. So you might ask why we are seeing a significant difference between these definitions. And to answer that, I have to introduce something else that we call RER, or renewable energy ratio. So it tells us how much renewable energy we are generating in the building with respect to our total site energy use. And as I already mentioned, total site energy use is the same in all the cases that we have. So as you can see, the RER for each definition is presented here. Emission definition allows the smallest renewable energy system, and cost definition, on contrary, allows the largest renewable energy system. So as we observe, as the RZR increases, so does the effectiveness of the definition on the reduction of GHGI. So, and in the reality, all these different definitions are different ways to size our renewable energy system in a net zero energy building. So we kind of answer, and we observe that like RER, or amount of energy that we generate, have a very strong positive correlation with the effectiveness of the definition on reducing our emission. So, but I'm specifically interested in this definition because it was supposed to be net zero, but as we can see, it's not even close to being net zero. And I want to answer that. I want to get into why we're not seeing a good effectiveness around emission definition. And to answer that, we should look at the way that we're designing this specific building. Again, we're in accordance with CAGBC ZCB standard. So it says you have to create a balance between the amount of emission that you produce and the amount of emission that you avoid. But the standard prescribed applying average emission factor to the amount of electricity that you're using from the grid and marginal emission factor when it comes to displacing some electricity on the grid, or how much credit are you receiving for the electricity that you're exporting to the grid. And when we look at the numbers for the province of Ontario, we see a huge difference here. So 31 grams is the average emission factor for the province of Ontario, and it's 134 for marginal emission factors. So this difference between the emission factors result in a undersized renewable energy system in case of net zero emission buildings. So that's why we're seeing like that the emissions are not even close to 1. And we said, okay, now that we know how effective they are in reducing the GHG, let's look at the resiliency as well. So we introduced another metric we call resiliency factor. It's the ratio of directly consumed renewable energy, the amount of renewable energy that you directly use on site, divided by the total site energy. So as we can see, the resiliency factors is not that different between these definitions, especially for these three, meaning that the RER, which is significantly different between these definitions, is not the dominant factor anymore. Our energy behavior and the energy mix that we use in the building are also very important when it comes to resiliency. But at the same time, we shouldn't forget that cost and ZEP, because of having a very large renewable energy, has a way more potential to be completely autonomous if the grid goes down for a really long time, because in that case, we can change our energy behavior, use more energy during the day when we have the energy, or we can install some batteries in the building to make sure that we can store that energy and use it at night. So, okay, I guess that was it. So I'm gonna conclude. Before doing that study, we already knew a lot about these 4 different definitions. For example, we know that site definition and cost definition are easily verifiable. We also know that these 3 definitions are subject to some external factors, meaning that we have more uncertainty to deal with. And in other words, they're prone to not meeting the goal if these external factors change. And we also knew that cost definition, emission definition, both have a more complicated design process. And I guess our study was able to add to this table. So these are our findings. So first of all, cost definition is the most effective definition in reducing emissions in the province of Ontario. It's the most resilient one, but at the same time, it's the hardest one to achieve because we need a very large renewable energy system, and the area available is usually limited. On the other hand, emission NZEP or emission definition is the least effective one and is the least resilient one in the context of our study, but on the other hand is the easiest one to achieve. So it might be a good starting point for the industry. And finally, site NZEP or site definition allows permits close to zero or net zero emission level. So if it was me, if I was in the place of choosing a definition, I would go with site definition. It's very simple, robust, straightforward. It's easy to understand. The design process is very simple. It's actually providing us net zero. It's getting us to net zero emission. So why not using that? And that's it. Thank you so much. Thanks for your attention. And if there's any question, I will be glad to answer.